Hello, my good fans out there. I remain Dr. D.I. June, your lecturer on chemistry on social media. We have been dealing with vapor density and its relative molecular mass. So let us see some few calculations based on relative molecular mass and vapor density. So you can see on the board here, calculations on relative vapor density of gases. See number one question that is before us here. Calculate the vapor densities of the following gases from the data given. A. 560 cm cube of oxygen at STP weighs 0.8 grams. B. 1,400 cm cube of sulfur 4 oxide at STP weighs 4 grams. C. 1,510 cm cube of carbon 4 oxide at STP weighs 3 grams. You were asked to determine the vapor densities of the following gases: oxygen, sulfur 4 oxide, carbon 4 oxide, and that at STP they are weighing these grams. So we are left to determine the vapor density of each of them. For time factor, let us take the A part of it, which is for oxygen. But remember this fact when we were talking about relative molecular mass and vapor density. Avogadro says one molecule, the mass of one molecule of a gas, all over the mass of one molecule of hydrogen is vapor density, or the mass of one molecule of the gas all over the mass of one atom of hydrogen is vapor density, or the mass of a given volume of a gas all over the mass of equal volume of hydrogen is vapor density. So these are things you must always relate. Now, having this fact, let us go. Now, note this conversion first. 1 dm cube is equal to 1 liter. In other words, 1 liter is equal to 1,000 cm cube. These are conversions you must know always in your head. Now, let us go from question 1 here. 560 cm cube of oxygen at STP is weighing this. So, volume of oxygen at STP, 560 cm cube, which is here already. Then the mass of oxygen at STP is 8 grams. It is here already. It's given here. Look at it now. 560 cm cube of oxygen at STP weighs 0.8 grams. It's already here. Now, what we want to do first is, because it is going to be compared to the equal volume of hydrogen. So now, since 1,000 cm cube, which is a dm cube, 1 dm cube, of hydrogen at STP weighs 0.09 grams. This is already a constant, which you must equally know that 1 dm cube of hydrogen gas at STP weighs 0.09 grams. It's a constant. So you have already known that. So therefore, if 1,000 cm cube of hydrogen at STP is weighing this, then for 560 cm cube of hydrogen, how many grams would it weigh? It will not give you 560 multiplied by 0.09 all over 1,000. That gives you 0.05 grams. So it means that the equal volume of hydrogen at 560 cm cube at STP will weigh 0.05 grams. That is now known. Now let's come to the vapor density. Vapor density says what? the mass of a given volume of the gas, in this case now is oxygen, all over what? Mass of equal volume of what? Hydrogen. Now, this is the equation. Let's now substitute now. Now that means that mass of 560 cm cube of oxygen all over mass of what? 560 cm cube of what? Hydrogen, because equal volume of hydrogen. Now, having seen this level, we now substitute the values based on the grams. Now, vapor density will be equal to 0.8 grams of what? Oxygen, all over what? 0.05 grams of what? Hydrogen. If you calculate this, you have 16 grams. Now look at it now. We said 2 times vapor density is relative molecular mass. Now, 1 atom of oxygen weighs 16 grams. That means the atomic mass of 1 atom of oxygen is 16 grams. So if there are 2 oxygen, if it is, we have 2, 0 to them is 2 times 16, will give you what? 32. That is why if you have O2 as the formula of oxygen gas, the molecular mass of it is 32, because 1 atom of 16 grams times 2 is 32. So here we have 16 grams. That is the relative molecular mass of oxygen based on this calculation. So for time factor, we will not go to B and C. And we'll come again, we'll calculate the B part and then also the C part when time permits us. So please like it, comment, follow me. Always subscribe to my YouTube. God bless you.